Welcome back, game developer hobbyists! In the last episode, we got things started by simply displaying a splash screen. Now we're going to get started on the actual game, allowing the player the ability to move the snake around on the playing field. The first step will involve the display of the playing field and some of the user interface elements. We're going to show the current length of the snake in the top left corner and the longest snake in the top right. Much like the splash screen, we'll organize this into separate classes for the controller and renderer. At this early stage, the Quick Game Controller class only needs to handle one additional input, when the user presses the escape key. The Quick Game Scene Client Request Enumeration is how we'll be telling the Game Client class that the user wants to return to the splash screen. If we look at the Process Quick Game Event function in the Game Client, we can see that it responds to this request by changing the mode back to the splash screen. In the main gameplay loop, the current mode determines which controller to delegate event handling and rendering to. The Quick Game Renderer class is where the majority of the changes are for this task. In the constructor, we initialize all of the graphical components we'll need for gameplay. The SFML text class will be used to draw the snake length and longest snake at the top of the screen. The instructions text will appear in the center of the screen. To determine its position, we need a way to calculate the full width of the text. The font utils namespace provides a function called resolve text width to figure this out. To initialize the sprites for the grass and shrub barriers, we also have a Quick Game Renderer utils namespace. The setTextureRect function on the SFML sprite class allows us to create single image files that contain many of our graphics. These are referred to as tile sets or texture atlases. Rendering of the game will be split into individual functions for each graphical component. The render playing field function first draws all of the grass, one tile at a time. Then it draws the shrubs along the top and bottom, and left and right, to act as a boundary. The render score UI function draws the snake length and longest snake information. Since the game isn't running yet, we just use 0 for the current and longest snake. And here's what this looks like. We have the playing field, now we need to get the snake moving around. The next task is to design the structures used to keep track of the game state. I decided to organize this into a Quick Game class to store the overall state of the game, and a separate Snake class to keep track of the state of the snake on the playing field. The Snake class consists of a head, a list of body segments, and a tail. The Snake segment struct consists of a segment type, its position on the playing field, and the direction that the segment entered and exited that position. The direction information will be used to determine how the segment should be moved when the snake moves forward. The snake start definition struct is used to define the starting position of the snake. Looking at the snake class constructor, we see how it's used to initialize the head, body, and tail segments. The head starts at the given head position, which it entered in the given direction. The head's exit direction is always set to none. Each body segment will be initialized to be one consecutive tile away, with its enter and exit direction both facing the given direction. And the tail segment is initialized to the same as the body segments, with the exception of the enter direction, which is always none. The isValidMovement direction method will be used to determine if the requested movement direction is valid. We won't allow the snake to turn directly back on itself. Movement of the snake is split into separate private functions for the head, body, and tail. When moving the head, we only need to update the position and enter direction. When moving the body, we update the position of every segment based on the previous segment's enter direction. And when moving the tail, we update the position and the exit direction based on the last body segment's enter direction. When the snake grows, I decided that the entire existing body will move forward, and the tail will stay where it is. We'll add in an extra body segment in front of the tail. I should mention that I later discovered that there is a bug in the movement code here. We'll get to that in the next episode when the snake starts eating apples. The Quick Game class will be responsible for maintaining the state of the gameplay. We initialize it with the Quick Game Definition struct, which specifies the field size, snake speed, and snake starting position, which apparently all gets ignored with this commit. I'm sure that will be fixed in the next task. The update function will be called once per game loop. It accepts an input request and returns a custom update result. Customizing these parameters will allow them to be adjusted in any way we like during future development of the game. Internally, we will keep track of the number of frames since the snake moved, and the most recent snake movement input. The update method starts out by updating these internal variables. If it's time for the snake to move, we first figure out which direction it should move. If there's no queued input, it will just keep moving forward in its current direction. If moving the snake would cause it to run into a barrier, the result indicates as such. Otherwise, we just go ahead and tell the snake to move forward. At this stage, the snake and quick game classes aren't yet used in the game. So the next task is to update the quick game controller and game client to let the player control the snake. First looking back at the quick game constructor, it has indeed been updated to make use of the quick game definition information passed in. For now, these values are hard-coded into the constructor of the quick game controller instead, where a future update will see them become configurable with menu options. There is also a new quick game mode enumeration, which is used to indicate the state of gameplay. For now, the player is either waiting to start a game or playing the game. In the process event function, we now process keystroke events based on the current mode. When the game is running, we accept either the WASD keys or arrow keys to control the direction of the snake's movement. The new update function sets up the input request and calls the quick game's update function. If the result indicates that the snake hit a barrier, then the game is ended and we switch back to waiting to start mode. The render function has also been updated to delegate drawing to the window to a different function based on the current mode. In the Quick Game Renderer Utils namespace, we now have a set of new utility functions used to create the sprites for the snake's body segments. For the head and tail, we only need to know the direction the segment is facing. For body segments, we need to know both the enter and exit directions. In the snake tileset texture, each body segment graphic is slightly different. The new render game running function will render the playing field, snake, and score user interface. In the render snake method, we choose to render the snake starting with the tail and working our way to the head. At this point, the snake can't run into itself. So if the player does so, it will give the appearance that the body segment closest to the head is over top of the body segments closer to the tail. In the game client, the only extra thing we need to do is call the Quick Game Controller's new update function. And here we have it. Our snake is now moving around on the playing field. In the next episode, we'll go through the code changes needed to spawn apples, make the snake grow and collide with its own body, and add sound and music during gameplay.